So we've made it to 4.3. We've gone through all the different setups for logs and sort of what the heck a logarithm is. The next thing is to look at some of their unique properties. So we're going to look at 3 rules, and they all kind of tie back to different exponent rules. We'll list the rules first, and then we'll sort of run some examples of what each of them looks like. So 3 log rules. And as we go through these, one thing to keep in mind is we can essentially run each of these rules forwards and backwards. We'll obviously sort of get into this more once we do the examples. So the first one is called the product rule. Product, of course, means multiplication, and so what this looks like is if you have the log of a product, right? So log base b, and you have some sort of multiplication happening within the log. It turns out this can actually be sort of expanded into 2 separate logs that are added together. So the log base b of m plus the log base b of n. So the multiplication inside the log essentially becomes addition outside of the log. I'm not going to get into the details, but this is sort of, we'll say this comes from the exponent rule, which would be something, right, like a base value b raised to the m times a base value b raised to the n. If you have the same base and you have things that are multiplied together, what happens is you end up adding the exponents together. And so because our logarithms, in some sense, sync up with the powers, there's a similar type of a relationship where there's sort of a multiplication that becomes addition and vice versa. The next example, the next rule, is our quotient rule. So product means multiply, quotient means division. So this is going to be the log base b of a fraction, right, of a division. So m divided by n. And what happens here is you're going to get 2 individual logs, but instead of them being added together, it's a subtraction. Because it's subtraction, of course, the order is important, and it's always going to be the sort of numerator value minus the denominator value. So 2 separate logs where you have the sort of log of the top minus the log of the bottom. This again kind of matches up and sort of comes from what is sort of a quotient rule for exponentials, right? Which is if I have 2 different sort of exponential guys where I'm dividing them, what happens is I'm going to subtract the powers, the top from the bottom. So there's a similar kind of relationship and connection happening here. Third rule, what we're going to call our power rule. So this probably has to do with powers, exponents. So this is log base b. We'll do m raised to the p. And in some sense, this is really an extension of the multiplication rule, right? I mean, in theory, this is m times m times m times m, right? Log of m, log of m, log of m, log of m, all added together. P many times, if this was cubed, right, it would be m, 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 so that would be log m plus log m plus log m, which would just be 3 of those logs all in a row, right? 3 times the log of m. So we can kind of generalize that, and what we're going to say is call this p times the log base b of m. So you end up doing sort of a multiplication by this power out in front. This again is kind of similar to a power rule, or rather an exponent rule. So this sort of comes from and is connected to, if you've got, right, something kind of power raised to another power, what happens is you end up multiplying those 2 exponents together. We're not going to get into the details of these connections, right? You can kind of do that as a fun little sort of exercise or experiment to see if you can kind of, go through what the exponential sort of versions of all these logarithms would be, and just to sort of justify that all these setups work. So let's take a minute and just kind of run these guys individually, just sort of one at a time, and let's sort of just see what it would look like. Just like run a couple examples. So if I've got log base 3 of 9 times x, so individually that's not particularly anything, right? But then what happens here is if I've got multiplication on the inside, I can call this log base 3 of the 9 plus log base 3 of x. And then this is useful, right? Because log base 3 of 9, this is actually just going to be a number, right? 3 to the question mark is 9, so that would be 3 squared. So that whole log just becomes a 2. And so part of what we can do here is when we sort of break these up and rewrite them, you know, potentially if we've got something with sort of numbers and variables, our number terms could actually simplify down in some instances. That's not always going to happen, right? You could get something like, let's say you have natural log of 6 over z. So that's going to be the natural log of 6 minus the natural log of z. The natural log, of course, is log base e, and so it's not particularly the case that that really gets us anywhere. Neither of those are really able to simplify anymore. The natural log of 6 is just going to be some like decimal number, and the natural log of z, well, obviously would depend on what sort of value we're subbing in for the z. Our sort of power rule, right? If I had, let's do a regular log. Let's do of, right, x to the 4 or something, right? So this is log base 10. The idea is that this is just going to be the same thing as 4 times the log of x. So using these rules just kind of one at a time is relatively straightforward. The idea here is that the more interesting things will happen when we start to combine them together. And what I said before is that we're going to be taking these rules and sort of running them, in some sense, both from left to right, but also from right to left. Maybe I should show you guys some right to left examples just so you've seen that too. So if we kind of reverse this a little bit, right, or from a different perspective, you could take something like log base 4 of like x plus log base 4 of y, and the idea is that you could actually take this and combine that together into the log base 4 of x times y. So sometimes it's helpful to use this to expand your logs. So take a log with like a couple different pieces, something that's a little bit more complicated inside, and then expand it out. Or vice versa, if you have like multiple logs together, right? Or if you have something like 7 times log base 6 of w, right? The idea is you can say, okay, so then that's really log base 6 of w raised to the 7. So these rules sort of work in both directions depending on what you're trying to do. If you're trying to sort of get an individual log, just like one log term with maybe a little bit more happening on the inside, you can do that. Or if you have a log with a lot of stuff on the inside and you're trying to expand it out into simpler and simpler logs, you can go that direction too. So both of these things are possible, and that's how we get started.